In this video, we're going to take a look at quadratic equations. So section 3.2, quadratic functions, the graph of a quadratic is a parabola. So if you take a look, what are some characteristics of parabolas? Each parabola has a vertex. That's either the maximum or minimum point. It has a y-intercept, crosses the y-axis. It may or may not have x-intercepts. This particular graph has two x-intercepts. The graph next to it doesn't have any. Those are the places where it crosses the x-axis. And then an axis of symmetry. Axis of symmetry is the vertical line, x equals whatever value it goes through the vertex, so it equals the x-coordinate of your vertex. So taking a look at the graph to the right, let's identify each of these characteristics. First is the vertex. So the vertex is the lowest point, and in this case, that's the coordinate 3, 1. So that's our vertex. The axis of symmetry is the vertical line that goes through our parabola. So that axis of symmetry would be x is equal to 3. The zeros, there are none. There are no x-intercepts, so zeros and x-intercepts are the same. There are no zeros. And then the y-intercept. The y-intercept is where our graph crosses the y-axis, so in this case, x is 0, y is 7. The domain and range of our function of a quadratic, the domain is actually refers to the set of all x values that are possible. You can put any x value in and get an output. So the domain is all real numbers. The way to write that in interval notation is negative infinity to infinity. The range will be limited. It's the set of all y values that are the outputs. Notice this parabola has a minimum point at 1 and then nothing below that. So this is all of the y values that are greater than or equal to 1, or another way to write that in interval notation is from 1 to infinity. So the graphs are parabolas. The general form of a quadratic is ax squared plus bx plus c. So x squared is the largest power. And in this case, it's also where a can't equal 0. It has to have an x squared term to be a quadratic. If you want to find the vertex, if it's given in general form, there's a little formula. The x-coordinate of the vertex is negative b over 2a. The y-coordinate is what you get when you substitute negative b over 2a back into the function. The x-intercepts for any graph, you let y or f of x equals 0 and solve for x. You can either factor or use the quadratic formula, and I've got it written here. The y-intercept, you let x equal 0 and solve for f of x or y. So in our example, we've got a quadratic where a is equal to negative 3, b is equal to negative 8, and c is equal to 12. I have a negative in the front. This tells me that my parabola is going to open down instead of up, so I'm going to have a maximum value instead of a minimum. So let's find the vertex first, because that will let us know what our axis of symmetry is. I've got the answers here as well. The vertex, the x-coordinate, is negative b over 2a. b is 8, negative 8, so I would get negative 8 over 2 times a, which is negative 3. That gives me 8 over negative 6, which reduces to a negative 4/3. So that's the x-coordinate of the vertex. That's also the equation of the line of symmetry, x is equal to 4/3, negative 4/3. Then f of x, f of negative 4/3, would give me the y-coordinate. So I would substitute that in to get the y-coordinate. So that would be negative 3 times negative 4/3 squared minus 8 times negative 4/3 plus 12. And if you multiply this out and add your fractions together, what you'll end up with is that answer of 52/3. All right, next we want the vertical intercept. So that's part C. The vertical intercept means let x equal 0. And if we put 0 into our function, we will end up eliminating both of the x terms and we'll be left with positive 12. So we end up with 0, 12 as our vertical intercept. Horizontal intercepts mean we take our function and set it equal to 0. So we have d, we take our equation, negative 3x squared minus 8x plus 12, and set it equal to 0. That's not factorable, so we're going to use quadratic formula. X equals negative b, which is negative 8, plus or minus the square root of b squared, that's negative 8 squared, minus 4 times a, which is negative 3, times c, which is 12, over 2 times a, which is negative 3. So do a little simplifying, and what we'll end up with is, I've got it down below here, we've got x equals 8 plus or minus, the inside of the square root will end up being 208, we'll end up with 64 plus 144 over negative 6. That'll be 8 plus or minus the square root of 208 over negative 6. 16 goes into 208. That's the square root of 16 times 13, which gives us 4 times the square root of 13. And that's what I've got down here. Let me erase this piece. We end up with 8 plus or minus, oops. We end up with 8 plus or minus 4 times the square root of 13 over negative 6, which reduces to 4. 2 goes into each of these. You can reduce, divide out 2 in the numerator denominator, and we end up with 4 plus or minus 2 times the square root of 13 over negative 3. So that's your solution. If they want it exact, this particular asks for your solution to the nearest 2 places. So you would put this in the calculator, 4 plus 2 square root of 13 over negative 3, then 4 minus 2 square root of 13 over negative 3, and that's how you end up with these 2 values. So when we graph this, just to make sure that we can do that, you graph each of the pieces that you found. You graph your vertex at negative 4/3 and about 52/3, which would be up here. 0, 12 is your y-intercept. Estimate best you can. You would label 1.07, and what your graph will do is it will do this. Okay? You can also use Desmos to graph, and I've already got it graphed on Desmos. I've typed it in. What I need to do then is adjust the y-intercept. So I need to go up further. So I'm going to go ahead and go up to about 20. There's my graph. Click on your graph and notice there's your vertex, your y-intercept, and your 2 x-intercepts, just to check and make sure you're right. All right, next item we're going to take a look at is standard form. We also call this vertex form. So the vertex, if it's in this form, you get a times x minus h squared plus k. hk is the vertex, so no work required. For x-intercepts, you still let your function equal 0 and solve for x. Your y-intercepts, you let x equal 0 and still solve for y. All right, so find an equation for the graph shown below. So notice we're given a graph, and we're given on the graph that the vertex is what? Negative 3, negative 1. So how do we use that to find the equation? Substitute your values into the function. Negative 3 is h, negative 1 is k. We get y is equal to a times x minus h would be x plus 3 squared, and then minus 1. And now what we're left to find is a. So select another point on the graph. Wherever you can see one, there's a point, negative 2, 1. Substitute x equals negative 2, y equals 1, and you'll find a. So we get 1 is equal to a times x, which is negative 2 plus 3 squared minus 1. So I get 1 is equal to negative 2 plus 3 is 1 squared, which is just a. Add 1 to both sides. A is equal to 2. So the equation of this graph is y is equal to 2 times x plus 3 squared minus 1. All right, next example. What if you have the equation and you want a graph? So a couple of different ways you can do that. Find your vertex. By looking at the equation, it would be 2, 2. So 2, 2. And then you can find another point on the graph. You can probably take f of 0. We get negative 2 times 0 minus 2 squared plus 2. That would be the y-intercept by letting x equal 0. That gives me negative 2 times, let's see, negative 2 squared is positive 4. Negative 2 times negative 4 is negative 8 plus 2, which is negative 6. So I found my y-intercept is 0, negative 6. That means that I'm going to have, by symmetry, another point exactly symmetric to on the other side. So that should be enough coordinates to find your graph. If that didn't work, you could also find the x-intercept. You could take your equation, negative 2x minus 2 squared plus 2, and set it equal to 0, and then solve for x. Don't multiply it out. Take the 2 to the other side. Divide both sides by negative 2. I get x minus 2 squared is equal to 1. Then square root each side. When you square root each side, you end up with a plus or minus. So I get x minus 2 is equal to plus or minus 1 when I square root both sides. That means you would get x minus 2 is equal to 1. X minus 2 is equal to negative 1. So your x-intercepts are at 3 and 1. So there's 3 and there's 1. So you could also find your x-intercepts. All right, so last idea, taking a look at application problems.